Thanks, Michael. Yes, my name's Matt Lyons. I'm a program manager just down the hall from Michael in the Security Engineering and Communications team. And one of my big jobs is to help perform the security audits that we do at Microsoft before we ship products. And what I want to specifically talk to you about today is something that we're seeing growing at Microsoft, and I hope that you're seeing growing as well, and that's the use of managed code and the security benefits that you get from that, and also some of the security concerns that you still have to have around untrusted data. So let's just jump right in and look at some of the buffer overrun issues. Now, as Michael had mentioned before, buffer overruns are a huge problem that we're seeing in C and C++ code. But let's just look at this example in C# that's almost a direct translation of what we had looked at a little earlier. Now, in this case, again, we've just got a string of some data. We're allocating a fixed size buffer, and we're trying to copy that data right into the buffer. Now, what normally happened in unmanaged code was that, we had the smashing the stack, or is it on the heap, or do I need to worry about it? Well, in managed code, it's going to check the size of the destination buffer before it copies the data in, and it's going to raise an exception if the source state is too large. And, that's it. Managed code has some great, huge benefits around security for this reason alone. I know when we've been performing some of the security audits, some of my team members say, well, is this written in managed code or unmanaged code? And when they hear that it's written in managed code, they kind of go, oh, shoot, I'm going to have to think a little more and work a little harder to find those really critical bugs. So really, managed code has some great benefits with buffer overruns. Now, let's look at integer arithmetic a little bit. One of the newer classes of categories we're seeing with exploits. Now, here's some code that you might have in some network service that's listening. You've read in some small number of bytes, and you know that there's a big chunk coming, and you've got some number from that buffer that is telling you how much is coming. And so we're just going to say, okay, well, we need to allocate one big array to hold all of this data. So we need to have the length of the data we've already got, plus the number that was passed in, allocate that array, and copy the data we've already got into that. Well, there's a problem in case, first of all, if that bytes to go parameter here in this code, if that bytes to go parameter is a really big number, then that addition is going to wrap around, and like we saw in unmanaged code, we could end up with a small buffer. But managed code is going to check the size of, or it's going to check that arithmetic actually in the byte array allocation, and we're going to get an exception right away. But let's say that bytes to go parameter was a negative number, like somebody pointed out earlier, can be a problem. So that allocation will work, and then we're going to try to copy the data in. But just as we saw with the last slide, buffer overruns are much harder to perform in managed code. So again, we're going to be protected by using managed code. So you might think, all input can be trusted in managed code, right? Well, unfortunately, that's not the case. Managed doesn't mean absolute security. Now, it has some great security benefits, but just as Michael was saying, you can't disengage your brain when you're writing managed code. There's still some things you have to worry about. And with code access security coming into play, you may have heard about that or heard that talked about at some other sessions. Code access security is great for semi-trusted scenarios, meaning if you're going to run like a stock ticker in your browser, it provides some guarantees that that little application can't read files from your hard drive. But again, it doesn't mean that all input can inherently be trusted in managed code. Something that Michael had mentioned to me a few weeks ago that's an interesting way to look at it is that all input is evil until proven otherwise. And what I mean by this, and what Michael meant by this, is that you've still got to validate the data coming in. You can't just blindly trust it and take action off of it and hope everything's okay. So let's look at an area where where managed code provides some security, but you still have to do a little work on your own. And that's with cross-site scripting. ASP.NET provides some mitigations for cross-site scripting attacks. It prevents, in the normal default case of cross-site scripting attacks, from stealing cookies, say, from one website, sending it to hacker.com, and having someone order something off of another site and charging it to your credit card. But the mitigations are not absolute. There are still some cases where you need to do input validation. And one of those would be if you have a user control and you aren't using the default ASP.NET controls, if you didn't put the mitigations in yourself, then that seatbelt to protect you is not there. And the second case is all the mitigation really does that are built in with ASP.NET is turn these elevation of privilege attacks with cross-site scripting into a potential denial of service or bad user experience. And so let's just look at an example of this. So switch to my trusty laptop. Oh, that's Michael's. Okay. So, sorry about that. Okay. So here we have, okay, sorry, I will need, did this come up? All right, sorry. So here we have an empty ASP.NET web application. I just opened it and created a new one just to save a little time. I haven't done anything in it yet. So let's look at this as if it was a new application we are creating. We're going to put in a text box, a button, and a label. And all we're going to do with this is to have some text typed into the text box. We'll click the button and show it in the label. So let me just increase the font size so everyone in the back can see it. Move this over a little. We'll come down. And one thing to note, so in this case, it's a pretty simple example, but you might actually have this data being stored in a database and it's going to be pulled up later. So just because it's a simple example doesn't mean that it's not showing us a good point. So let me just take out the default text in the label so we can see when we type something new in. And I'll just add a little bit of code. All I have to do is say label, if I can type, one.text equals text box one.text. Pretty simple. Let's build it and run it. And what we're going to see, is just the simple text box and button come up. And so let's put in just some simple text to start with, just to show that this is working as we expect. While this is pulling up, let me open up an example of some bad text we'll put in a moment. All right, so let's just say, good morning, PDC. And it works as we expect. Now what I'm going to do is put some JavaScript in here that again, just as Michael didn't want to type out a huge thing. This is just some JavaScript that would normally, in a standard ASP web application, would just pop open a new window and would display the cookie for the current page. But what happens when we run this in a default ASP.NET web application is we get this error saying a potentially dangerous value was detected from the client. So this is great. This is the default protections you get with ASP.NET. But let's say that these have to be turned off, or you want to see what happens if those protections aren't there. In the HTML, we can go in and say validate request equals false. Save it. And we'll just close this off and reopen. And we'll just go ahead and show that the application is still working as we saw before. Just put a test in there. But now let's put that JavaScript back in, and we'll see that a new window opens with the cookie. Now this is what we want to protect against. Now just because ASP.NET had the default protections, remember, we still don't want to see that nasty error page. So what's the right thing to do? Well, we should validate the data, just like we've been talking about. So a good way to do that in ASP.NET is to use, in the designer, something called a regular expression validator. So let me come in and, let's see, we'll go down and find the web forms, the regular expression validator. All right. And we'll just plop this right in. And again, I will quickly up the font size so everyone can see it. And just as a note, this is in today's Visual Studio.NET. This is not something you have to wait for in Whidbey. And we'll just give it some message so that if we hit something bad, then this is the message that will be displayed. We'll just say invalid input for now. And then we need to give it a control to validate, in which case we want it to validate the text box. So control to validate is going to be our text box 1. and then the validation expression. Now, this is a regular expression. If you're not familiar with regular expressions, there are tutorials on the web, there are books out there. They're not too hard to learn. So I'm just going to put in an expression that says any word, characters, or spaces are allowed, and nothing else. And that's going to be the entire thing we're going to allow. Oops. And rebuild this with our now regular expression validator in the code to validate the input before we do anything with it. And then let's close down our IE and reopen it. And again, let's just look at the test data that we're putting in just to show that it's still working as we expect. All right, now let's put in that JavaScript and see what happens. We immediately get an invalid input message from the validation control. Now, in this case, it's actually pushed down some JavaScript to do validation on the client, but if I was a hacker and bypassed that and sent it in anyway, it would also do validation on the server. So here we've got some great built-in support in ASP.NET that you can use to validate input in a smart way so that users, first of all, aren't attacked by these cross-site scripting attacks, and secondly, don't see these nasty error messages that are better than having a cross-site scripting attack, but still not a great user experience. All right. Oops. Other way. Okay. So integer arithmetic is something that we had talked about a little bit earlier. And we had shown where the buffer overruns that come from integer overflow attacks are hard to bring about and manage code. And this can still cause security problems depending on what your application's using the arithmetic for. So here's a little bit of code that you might see in an application. We have a large array of objects, and we're trying to reserve a small set of them to store some kind of secret system data. And we only want to allow users to get to everything else. And the way we're enforcing this is through arithmetic. We're just going to add 20 to whatever the user passes in to try to push them outside of the system data range. And we're using an unsigned integer here so that we don't get that problem with negative numbers being passed in. But we still have
and have it as part of the process. And in fact, the rest of the symposium is all about that call to action, which is implementing best practices, a good process, and then we'll show you some solutions at the end of the session.
You can just verify the arithmetic. So you could just say in this case that the item number plus 20 is greater than 20. You could just apply ranges to your input, which in this case would mean that the item number has got to be at least no more than 480. Another piece you can use in C# are these checked semantics. And that you can use the keyword checked, have a block of code, and if any overflows or underflows occur in that code, it's going to throw an exception that you can handle right away. And something else that you can use is just VisualBasic.NET, because .NET will automatically throw an exception and allow you to capture it and process the error and move on properly.
High-level language, where appropriate.
Surround more the person or user or account or whatever sending the data rather than the data itself. Remoting has two built-in channels, HTTP and TCP. Now, if you're using the HTTP channel, you can use the built-in authentication mechanisms in IIS and have some, basically free authentication that you don't have to add any code yourself for. But if you're using the TCP channel, you're going through sockets. And if any of you have done socket programming, you know that there's no authentication there, which means that if you're using remoting over TCP, there's no built-in authentication. Now, that might seem kind of intuitive or simple when you think through it, but we've seen some cases at Microsoft even where people haven't realized this right at first. And an interesting case was about a year ago when we were looking at just an internal application that was new and being deployed around. It allowed us to control our telephones from our desktop machines. But they were using TCP remoting, and they weren't doing proper validation on the server side, which meant that I could control my neighbor's phone, make him call me or anyone else I wanted to. And we had a lot of fun for a couple days with this. But in the end, we actually needed to we ended up talking to the developers and pointing out the solution that is listed off of the URL you see you see at the bottom of the slide. And there's code on there that allows you to use the built-in SSPI infrastructure in Windows with remoting through the remoting sinks that allows you to then authenticate your clients through TCP remoting. And this in and of itself allows you then to know who the data is coming from, and if you know that you're going to trust the data at least coming from a certain authenticated client, it allows you to give, you have a certain level of confidence at least in that data. So let's look a little bit now at SQL injection. SQL injection is something that it seems to be more common than what I've realized before I started doing some of these security audits. And unlike what we've seen with cross-site scripting with web applications, there are no free mitigations for SQL injection. And this is true not just for Microsoft SQL Server, but for any SQL Server that you're using. SQL injection is something that depending on the scenario where it's coming into play, can actually have a pretty devastating impact on your application. So let's just look at an example of this and what we can do to protect against SQL injection attacks. So we're left with the application as we left it, but I've got another project that I'm just going to open here that's got It's basically a small SQL application that someone might have on their website. In this case, it's got a list of books, some fictitious, some real books, with their titles and authors and a rating that I've given them from 1 to 10. And I might put this up on a web page to let people see what I think of these books. And I might have many, many books, so I've given a search capability here so that I can. Now, what normally happened in unmanaged code was that, we had the smashing the stack, or is it on the heap, or do I need to worry about it? Well, in managed code, it's going to check the size of the destination buffer before it copies the data in, and it's going to raise an exception if the source state is too large. And, that's it. Managed code has some great, huge benefits around security for this reason alone. I know when we've been performing some of the security audits, some of my team members say, well, is this written in managed?
Up on stage, primarily because there are a series of defenses, but the big one by far.
But the first. And what I want to specifically talk to you about today is something that we're seeing growing at Microsoft, and I hope that you're seeing growing as well, and that's the use of managed code and the security benefits that you get from that. And also some of the security.
Those now.
Thanks, Michael.
To manage code
with.
There are some. I would like to invite Matt Lyons up on stage.
That's the key problem here. We haven't validated the user input. We're just sending it in with the rest of the command text. And SQL has no way of knowing what's supposed to be data and what's supposed to be command text. So what we can do to help out with this, we'll just get rid of this buggy code, is to put in some code that uses parameterized queries and stored procedures. So what I have in my SQL database is this stored procedure called getBooksByTitle. It's the exact same SQL statement that I had embedded in in this application earlier. It's just in a stored procedure now. And now I'm giving it a parameter for the title of the book and sending in the user data for this. So let's build this. And then we're going to go back and look at this SQL application again and see what we can do now with SQL injection. So as this is coming up, let's look for, again, let's look this time at cooking and see what we see, just to show that it still works. Okay, that's still working. Now let's put in this SQL injection attack again, but this time let's change the rating. Let's say that I was trying to change it back from a 1 to a 10 through this. Now what's going to happen when I hit search is that it's going to send this text to the SQL database, but SQL, because we're using a stored procedure, is going to know that this is supposed to be data, not command text. So it's going to look for a book with all of this gobbledygook in the title, and we're not going to see any. So we're going to come up with this, and so we can no longer change the ratings or drop tables or run arbitrary commands on SQL or whatever else we could do through SQL injection. So again, using stored procedures with parameterized queries is a great way to protect against SQL injection attacks. All right. Now, one more issue that I want to leave you with that.
But there isn't. It's a whole series of things that you have to do, a series of remedies and a series of defenses. But the big one by far is process improvement, changing the process so that it fosters people building secure software. And on that note, I would like to invite Matt Lyons up on stage. It's in the process so that it fosters people building secure software. And
CLR early on. What we were trying to do in a certain processing path was to filter out file URLs because we knew that for some reason, those were not trustworthy in the path that we were going through. And we were trying to filter those out by just looking for the first 4 letters of the URL as FILE, moving them to uppercase and comparing it to English FILE. Well, in Turkish, of course, this comparison says they're not equal, so we go ahead and process the URL even though it's a file URL. So when we realized this, we took a step back and said, well, what are we really trying to do here? We're just trying to process HTTP and HTTPS URLs. So what we did was step back and say, well, let's just look at the first 4 letters, compare it against what we know is good, and then throw everything else out. So here, then we just took the 4 letters, used the invariant culture to move it to uppercase, and compared it to HTTP, and then we got rid of this problem. So this is this is something that you might not realize and might not find in your normal testing, but it brings up a good issue, which is that you can't really assume that you know what all the bad data is. You can't filter out based on what you think is bad and take everything else out. You can't filter on everything what you think is bad and assume everything else is good. You've got to try to figure out what you know is good, take that, and throw everything else out. So, 2 things I want to leave you with today. First of all, use managed code when it's appropriate. It prevents or mitigates some of today's common security problems, as we saw with buffer overruns and integer overruns, or integer arithmetic attacks. It prevents a lot of attacks that we've seen. And the second thing is that you should continue to validate untrusted data. As we saw with several examples here, just because you're using managed code doesn't mean that you're free from security problems. Managed code will help you out, but you've still got to pay attention to the untrusted data coming in. And to give you a few resources to help you out, the first 2 here are a couple of books, .NET Framework Security and Writing Secure Code 2nd edition that you've already got. And here's some URLs, and you've also got the sheets that were on your chairs when you came in. I really encourage you to do as Michael mentioned earlier, read up on this, do the training, and then apply it, hopefully using managed code to produce secure apps. So at this point, I will turn it back over to Michael to talk about some more security coding practices.
Well, first of all, I want everyone to know that's the first time I saw that demo where he changed the ranking on the book. That's the first time I saw it. Thank you very much, Matt. Actually, quite seriously, SQL injection attacks are actually are very serious. And I don't want to take any thunder away from the SQL guys, but many attacks that have been seen in the past where people could get credit card details are because of SQL injection attacks. And if you don't think cross-site scripting bugs are that serious, I know about 3 years ago of a couple of fairly large banks that stored your username and password in the cookie so that you could automatically log on when you went to their online banking system. And the bad guy can get that cookie through cross-site scripting bugs. So they're actually very serious bugs. Don't sort of put them away as being not as serious as buffer overruns. They're actually very serious indeed. So one thing that I want to point out is that Matt and I have focused almost exclusively on sort of tactical aspects to secure code. In other words, down the details, buffer overruns, cross-site scripting, bits and bytes, blah, blah, blah. That in and of itself will not actually create secure software. It just will not do it. I mentioned earlier, you can't just build stuff blindly of security, or design, build, test, code, ship, and expect to ship a secure product unless you have a process that actually fosters building secure software. So I'd like to invite James Hamilton on stage to outline some of the experiences that they have and some of the wisdom that they've learned over the last while in their process. Over to you, James.
Great. Thanks very much, Mike. It's a pleasure to see so many people out here. Pleasure to see so many people out here that care deeply about security. We're going to win. My job is responsible for a large part of the SQL Server development team. I'm also responsible for security across the SQL product itself. I drove the SQL security push. And what I want to do is share with you today some of the things we've learned during this push. From a beginning perspective, where do we want to start from? What I'd like to do is to start by talking about some of the risks that are out there and how they impact server-side computing. I want you to specifically see that the risks that are happening in the computing industry as a whole are spreading through to the server side in a fairly big way. I want to show a demo that was first shown to me by a gentleman from Argentina. He's an acquaintance of mine. He works in the community. He's shown an interesting demo at the Black Hat conference that sent a shiver down my spine, because what it did is it opened up a whole new class of issues with SQL injection, a much more powerful attack surface at a much lower IQ entry point. So we're going to demonstrate that to you and show you, what the risk really is. Now, from a plan of approach perspective, I could give you a bunch of rules of things you should look for and things you should do from a process perspective. That's neither interesting, and it kind of tends to say that we know all of the solutions, and I don't think we do. What I want to do is I want to take SQL Server as a case study, and we'll look at what SQL did, we'll look at the processes that we went through, we'll look at the tools that we used, and we'll look at some of the lessons that we learned. In addition to that, because most interesting applications have components of those applications that are database-based, I'll look a little bit briefly at the end of things you should do to secure a database application and how you can avoid issues. First, the time frame of what we're looking at here are cert security reports. If you look back to 1988, there were 6 reports. Last year, there were 82,000. This period of time is interesting for me because it's the period that I've worked in the relational database world. I worked on OS/2 Extended Edition 1.3 Database Manager, and back then, believe it or not, we had 0 security risks. Not a single threat in 1 year. Not one. And the funny thing about that product is if 2 applications were running both on the server, they both had the entire buffer pool mapped into memory. There was no security. Worse than that, if there was an error, an errant pointer in one of those applications, then in fact, the data was corrupted. So it was a different period of time. What's happened, first it happened in client-side computing, but increasingly it's happening in server-side computing. Everything's interconnected. Because everything's interconnected, the risk is going up. The reason why I wanted to show you this graph is I want to point out an observation that I've made. Server-side computing is going through the same trend, and it'll shifted down in time. So what that means is the risks that we're seeing mostly on client cracks today apply to server-side computing this year and increasingly into next year. So and the same reasons driving it, and that is all these systems are interconnected. If you want to check with UPS on where your package is, you don't call a UPS representative and they access the computing system. You go to the web. The web immediately accesses the back-end UPS system. You can directly contact UPS. That's a fantastic thing from a productivity perspective. But what that opens up is a whole new class of risks and issues, and education is the key to addressing that. Tools that are out there. This is an important point and one that I wanted to emphasize. There's a bunch of conventional tools that we all understand, brute force password crackers, dictionary-based password crackers. These have been around for a while. Some are a little bit more frightening. Object code decompilers. There's absolutely no safety in hiding anything in object code these days. There's wonderful decompilers out there. Further, just as the commercial software industry is building up the abstraction level, every time an operating system gets stronger or the database gets stronger, you can build better apps on top of that. The same thing's happening in the security community. The cracker community are writing tools to help you or help Black Hat community build up their skills. And you don't have to know everything in order to build a higher level tool. Well, some of these tools are getting very powerful. One that I found very disturbing was, this is also from a Black Hat conference. One of the three things you need to do to break into a software system, you first of all have to insert code. Second thing is, you have to get the thread of control to jump to your code. That's step 2. Step 3 is you have to get control of operating system resources. Having code running in a process doesn't help. You have to be able to call the routines that write to disk or write to the network in order to be able to spread or do damage. Now, as a consequence of that, this step 3 says you need to find where the socket write routine is, for example. So, in the case of Slammer, what it did is it went to the import address table of SQL sort.dll. Because SQL sort.dll is always in the same location, it just goes to a fixed location, loads that, and now it's past step 3. What that means is, as a SQL Server engineer, if I change the order of the DLLs, Slammer's defeated and can't do anything. So it sounds wonderful. Isn't that great? We could completely stop stage 3 of any of these attacks just by changing the order of DLLs. Now, unfortunately, a little bit smarter attacks, you can't do that. What happens is baseless loaders are being written that go looking for the import address table or similar places in code that have these handles to get access to operating system code. Because baseless loaders are out there, a bad guy can take a baseless loader, write the rest of his code around that, and not have to understand the intricacies of what the heck is an import address table, and where would I find it, and what order is it stored in. He doesn't have to know that anymore. So be fearful of the tools. What it means is the threat is substantial out there. Along the lines of tools, an acquaintance of mine, Cesar Cerruto from Argentina, wrote a tool that was demonstrated at Black Hat in Seattle. This is the last demonstration I wanted to show you. It is SQL injection, so you've already seen a little bit of this, but this one is a little bit more scary. The reason why this is scary is knowing nothing about SQL injection, this allows you to export the entire contents of a database system behind a firewall. This is an extremely frightening approach, and it emphasizes what's possible out there building on higher level tools. So let's look at the architecture of this. The first thing, on the left side of the screen, you see a nice UI. That's what the user actually sees. The bad guy copies a URL of a injection-prone website, copies it into the UI. Everything else is driven from the UI. The UI contacts the vulnerable application, constructs the string as necessary, accesses the back-end database that's supposedly secure behind the application, tunnels out of that application, and feeds information back to the bad guy. Now, because bad guys are dealing with potentially large amounts of information, this could be exporting possibly millions of credit card numbers. Well, that's hard to manage. You need some help with that, don't you? So he actually uses a database at the bad guy's site. And you know, it's troublesome to load databases, so in fact what he does is he does it for you. You run the UI, and what shows up in the database is all the contents of the back-end system. You can go ahead and ask questions about it, pick off credit card numbers, and get all the power of SQL Server. So Girish, I've asked you to come up here, and give us a demonstration of this tool.
Thank you. Suzanne, thanks. The mere fact that we're doing 2 SQL injection demos in a space of about 10 minutes should tell you how important a class of attack SQL injection has become. My goal here is to try and show you a more realistic scenario of where SQL injection can apply, but also show you how people are developing tools here to make this really simple. As James mentioned, really low IQ required to do this. So is this up on your screens here? Excellent. So what you have here is a typical electronic store. This one specializes in spy equipment. Now, As a random browser, web surfer, you could come by, browse through the various collections. And if you really wanted, you could sign in. And I've created an account for you here, James. So I'm going to go sign in as you. Oops, if I can spell Microsoft correctly. And all right. And James Bond Hamilton, you're up here. So I can go now and pick a category, like the fake mustache translator, add it to your cart, and then proceed towards the final checkout. Right? Typical way a legal user would try and use this website. But I'm hacker Girish. Now, I really don't want to pay for something I want to buy. I mean, where's the fun in that, right? So perhaps I could use SQL injection to try and get out some interesting pieces of information. Perhaps someone else's credit card number that I can then use to purchase items. So I'm going to try and browse through the site, see if there are any points of entry. I go look at the URL here. Well, the input here is an integer. It's not that easy to try and inject. I'm looking for a string input. So here's a part of the website that now it allows you to select stores from different states. So let's try and select the stores in the state of California. Now, the URL here is really interesting. It's a string input. Now, perhaps this is my lucky day. What I can try and do here is go and try and manipulate this URL. So I'm going to try and provide this closing single quote here, which typically, if the application is not written securely, is the way it'll wrap up a string input. And now, add my own part to the query. So I say or1 equals 1, and then comment out the rest of the query that the application might append to that. Now, this is a classic example. Now, if things work well, and if I'm lucky and the app is insecure, this now is going to try and return to me all the rows in that particular table. And there it is. So now I've successfully identified a point of injection in this application. Now, but that in and of itself is not really interesting because this is data I could have otherwise gotten. What I really want is to use this point of entry to get in some other pieces of information. So come in Cesar stool. Now, for those of you who might have seen a stool earlier, I modified this ever so slightly. So the way the stool works is the 3 asterisks that you see up here represents the injection string. Now, James pointed to this earlier. Essentially, it issues an ad hoc query to the backend database that then funnels in information from that database to my attacking machine. So this string has to be placed at the point of injection that I've identified. Now, let's go back to that page. This is the point of injection here. So let me just copy that. Go out to this tool and inject it here. And now I have it all set. Now, the tool supports both the get and post method. I'm going to choose the get method because that's what the form used. Hit go. The first thing the tool will do is return to me information about the version of SQL Server. It's up here in the version results here. This is particularly important because depending on the version number, I can actually see the patch level of this instance. And I could then potentially attack it with known or unknown vulnerabilities that I might know of. The other thing it does, it returns link server details. This is again useful because I can now propagate my attack across multiple hops.
What this means is that other systems that are accessible from this system are also now open to your command.
Open to my attack.
Great.
And the most important thing is the list of databases here. Now I look at the first few databases, and these are the standard set of databases. But the one really interesting one is the store. This must be the database that the application is using. So let's go in point and click approach, and now I have the set of tables associated in this database. Well, all this is great and nice, but the one that's really catching my eye is the customers table. This is potentially where people have their credit card numbers, right? So let's go click the fields on that table. There you have it. There's the credit card number, there's the customer ID, email address. Well, this is all great. So I'm going to basically go ahead and choose these. Run the query, and you have a text grid with all the information. Thank you. I'm particularly excited because that vacation I was telling you about, James, your credit card number just made that possible.
I just bought it for you?
Yeah,
That's great. Great. Thanks very much, Girish.
I'm going to go ahead and plan my vacation.
That's excellent. Okay, so what we're going to get into now is this is the kind of community we're facing out there. The reason why I wanted you to see that is it had a huge impact on me. What it told me is the maturity of the risk has gone up, and the tools that are available now are such that for even those that don't have a lot of skill, these kinds of attacks are possible. Now, the plan of approach for telling you about the SQL security push, what I'm going to do is I'm going to start by talking about the preparation phase. We're going to then go into talking about what happened during the push itself. And finally, at the end, we're going to talk about things we learned or lessons we learned from that. Starting at push preparation. The first thing we've got is we've got to be able to communicate to the entire team as a whole. When you're dealing with a large team, SQL Server was over 800 people at this time, communications is super important. Preparations are super important because what we learned from talking to other teams is if you just stop and say we're going to focus on security right now, what happens is you waste a lot of time. People don't know what to do. And so what I'm going to try to do is share with you some of the things that we've learned, and maybe you can make use of some of them as well. First one's communications. You can't communicate too much. You've got to learn from other teams. I learned from the work done by the Windows team, the work done by the IIS team, and the work done by VS.NET. I'm hoping to transfer some of that learning to you. You've got to have the team's got to be ready. You don't want to start the push until a couple things have happened. The first thing is it's good to have the code to a stable point. And the reason why you want to reach a stable point in the code is two reasons. One is if developers are still working on features, given the choice between code reviews and features, developers will always take features. It's just more interesting. There can't be a choice. You've got to absolutely lock down the system and prevent any forward development going on. So at the end of a milestone is an ideal time. That's one of the reasons why we delayed slightly. Second thing is you want to have the code stable. You don't want to have a lot of code checked out. You want it all checked in the same point so that what's being reviewed is all consistent. You need to have a security plan written, and the security plan describes the responsibilities of everybody on the team, what's expected, how the code reviews are going to work, what's going to be reviewed for, the tools that are going to be used, how we're classifying security bugs. It's just organizational issues so that you can track the progress as it goes on. We'll have education plan for the entire team, and I'll talk about that in a second. Finally, as well as having email communications, you want to have a website set up so that everything that's ever been communicated to the team is available on the website and can be searched for, because invariably people want to be able to go back to it. Training. This is perhaps the most important of all of the things that we can do, and that is most engineers, at least folks like me that were trained quite a few years ago, security wasn't part of the issue. Back in '88, I was already out of school. I remember the first SendMail worm came out. It was a new thing. You realize that you could actually start to push code in the stack and take over machines. All the engineering team needs to be trained. And the training that we used focused on a spectrum of things. The first thing is to train, here's why people are cracking systems. Here's the motivations behind it. Here's the tools they're using. Here's a class of vulnerabilities that we've found over the years. Here's things that here's things that have been found in competitors' products, and here's things that have been found in our products. Here's how you protect yourselves against some of these vulnerabilities. Here's functions that are open to attack, and here's what you look for in order to avoid those attacks. Mike Howard helped drive some of these sessions. He went through all of the vulnerabilities that were possible for every member of the SQL Server team. And when I say every member, I mean every developer, every program manager, every member of the leadership team, all the way up to Gord Mangione, who's the vice president that runs SQL Server. Every member of the team went through the same training. Well, I also run a special security talk series. And the security talk series was focused on helping people with stuff that was hard. And by things that are hard, what I mean is threat modeling was difficult. It turns out threat modeling is the core of what I'm going to tell you about, and need more training on how to do it. As we went on, we learned a few other techniques that we wanted to share more broadly. And so if somebody was doing a particularly good job, we'd get the whole organization to come in and see what they did. Turns out the data flow analysis is a particularly useful concept for approaching threat modeling. And the way we did that is we used data flow and control flow diagrams. So we did a session on here's how to build data flow and control flow diagrams, and here's how they feed into the threat modeling process. Many of this material is available to you. I've got a URL at the bottom of this page. Getting the infrastructure ready, having a cross-component team to help drive this was important. In SQL Server, I lead part of the development team, but there's 4 other main organizations, each of which is a couple hundred people. I need to have representatives from all the other teams that are my lieutenants in driving this. When we make a decision saying we're going to do X, we need people to bring back into their organization, into their teams, that this is what's happening, and make sure the right people are on it. In addition to that, we need to have bug tracking guidelines. And what we're after there is we need to say, here's the classifications that we're using for bugs, here's how we're going to track them, and I need to make sure that we've got ways of tracking progress through the process. The things you want to see are, if a team's not finding a lot of bugs, you need to find out why. If a team isn't reviewing code fast enough, you need to find out why. You do have to keep an eye on the process. One thing we did is we set up a separate bug base to track the actual review process itself. These aren't bugs. This is a way of tracking the review process. We've got thousands and thousands and thousands of files, over 5 million lines of code to review. So what we did is for every file in the system, we opened a bug. And the reasoning behind that is a couple. One is it helps us track progress. The second one is I want a lasting record in a database that shows who reviewed the code, who signed off on it, what bugs were found, when they were found. And the reasoning behind this is we want to learn as we go. And by learning, I mean tough learning as well. If I find out that Mike Howard, you reviewed 3 modules, all of which bugs were found in subsequently, that's a problem. We want to understand what's going on there, and we want to keep an eye on ourselves, and we want to learn from ourselves. So the bug base helps us understand who does a great job of reviewing and who doesn't, and it also makes us all accountable. We all are part of the process, and we're all responsible for the quality of what we do. We want to have clear guidelines for what's a bug and what's not, and what we're looking for. And as I said before, you've got to be able to track progress, because anytime you have a process that's hard to measure, and security is hard to measure, you need to track what's the progress that's being made and how it's being made. Okay, what you saw is the preparation, just setting the infrastructure up, getting aliases set up, getting teams set up, educating everybody on the team, setting up websites. That process of just getting started took almost 3 months. It involved me working full-time and some members of my team helping out. The security push itself is the next phase. Let's look at what we actually did. During this phase, what you're going to see is, first of all, it took about 3 months, and I want to stop for a second and realize what that means. That's an 800-person team stopped for 3 months. The burn rate on an 800-person team is about $11 million a year, rough numbers. Pardon me, $11 million a month. This is a very expensive project. It's one that we think has yielded tremendous value. Mike Nash earlier put up statistics showing bugs found before and bugs found after. Great value. We think it's a wonderful investment, but I don't want to underestimate it. It is fairly substantial. Okay. I told you the core of this process, the building blocks for this process is threat modeling. On the left side of the screen, what you see is we're bringing input into the threat modeling process. That input includes use scenarios. It includes external documentation, internal documentation, all bugs that have been found in this component in the past. We bring all that data in, make all that data available, and then we get into the threat modeling process proper. The reason we're tracking use cases or use scenarios is not so much because we only want to look at proper usage. That's not it. The reason we want to have the use cases there is they represent a constraint. When you're locking down the system and making it secure, you want to make sure the primary use cases are still operable. So you need to have that as a constraint on the system. Okay, for the threat modeling itself, we've got the system divided up. In the case of SQL Server, it was 228 independent components. It's very important the component boundaries are well understood by everyone on the team. Since we're going to be tracking data flow throughout the components, you need to know the data from this to get to this component came from this other component. And as you're tracking data flow through the system, you need to know where it was verified. So in order to take over a component or to use a component to do something of damage, what do you need to do? You have to get input to it. You've either got to get input through data. The data could come through registry keys, it could come through files, it could come through user input, but you have to get data to the component in order to take it over, or you have to get code, you have to get control to it. So if you track all the control points and all the data points to a component, if you track all of those and ensure they're all secure, nothing can happen. And that's why this is the right way to tackle these problems. Divide into components, track control flow, track data flow. Take data flow from every source, everything. Okay. Once that's done, you know all the data flows into the component. You can look at what are the risks. What are the things that can happen? What are the possible vulnerabilities? Once you've done that, you've got a vulnerability list. This analysis now feeds into two things. The first thing it feeds into is the code reviews. During the code reviews, I'm going to give everyone that's participating a checklist of things they must check for. In addition to that, they're going to have a list of vulnerabilities that are specific to their component, and they have to mitigate every one of those vulnerabilities. Each one's going to have a bug against it, and they have to say, I mitigated this vulnerability by taking these steps. This is important. You want every vulnerability tracked, and you want to know exactly who fixed it and what they changed. If you do this, it's almost impossible to make a mistake. As long as you've found all of the possible inputs and you analyzed what can be done with those inputs and closed off the risk, you've got a good, safe situation. Here's an example of a data flow diagram of SQL Server login processing. I won't spend time on it, but this is a good driver of the process. When we started off in SQL Server, we weren't really very dependent upon data flow and control flow diagrams. It turns out this makes things a lot easier. So I strongly recommend you take an approach along these lines. Threat modeling. When we're looking at threats, we're dividing them into a couple different categories. The first one is we're going to classify the threats according to STRIDE, spoofing, tampering, repudiation, information disclosure, denial of service, escalation of privileges. We're going to have a look at the severity according to DREAD. Damage potential, reproducibility, exploitability, affected users, and the ability to be discovered. Now, a couple of those we don't use in SQL Server because we don't believe in them. One of them is discoverability, and the other is exploitability. And the reason why we don't believe in those is, in my opinion, every vulnerability is potentially exploitable, and every vulnerability is almost guaranteed to be discovered. When software is out in broad use, it's a guarantee. So for those two, I just don't even look at it. It's a fact. If it's there, we're going to fix it. Another thing we found very useful, what I've described to you so far, if you watch carefully how we're approaching the problem, we've broken into components. We've got domain specialists from each component looking at the component. In addition to that, you want to have a cross-component analysis. It's important to have domain specialists looking at each component, the guys that really know that code best, but you also want to have some cross-system analysis. We nominated a set of security experts from across SQL Server, and we asked this team to go through the highest priority risks in the components in the system. Those components that have the most risk, what are those components? Well, any component that's open to a network connection is extremely high risk. We know that. So that's an example of something where this team that we'll bring together will go through and do a detailed review of every one of those components. And the way it works is the team who owns the component comes in and presents to the SWAT team. They present the architecture and they present the security mitigations and how they've designed it. This has two positive things happening. One is one team, the SWAT team, learns the best practices across the entire organization. The second thing is the SWAT team can stop the wrong approach. If someone's trying to solve a problem without using the power available in other parts of the system, we can get it fixed. If someone doesn't have the right approach, we can get it fixed. This is a team of specialists that will spot some common problems throughout the system. I strongly recommend taking this approach as well. The combination of having domain specialists on a per component basis and security specialists across components seems particularly effective. I've got an old saying, there's the safest line of code is the one that's not there. Dead code removal. A lot of people argue against this. We wrote tools to find dead code in our system. This is code that cannot execute. And what we're after here is if code can execute, get it out of the system. A lot of pushback saying, why? I mean, why would I get that out? A couple reasons. One is dead code is usually there for a reason. It may be turned on sometime in the future, and it won't get reviewed right. If people know the code's dead, they won't spend as much time reviewing it. The second reason is it's a fact of development that people clone code. People tend to take code as an example and then write their own code on the basis of it. If there's dead code in the system and it hasn't been properly reviewed, you're going to get cloned code that's bad as well. So generally, get it out. We wrote automated tools that went through, found dead code in the system, and automatically wrote bugs against it. And I was very hardcore about get it out of there. It's cheaper because we don't have to review it, and it's not open to those problems I just described to you. The code review's proper. This is maybe the most important part of everything we did. Here's the design we chose. We used 3 members in each code review team. At minimum, sometimes we used more, but you're guaranteed to have 3. One member of the team was the component owner. This is the person that knew it best. Another member of the team was a very skilled developer with domain expertise in that area. And the third member was a skilled tester with domain expertise in that area. Sometimes we'd have more, but you never have less than that. I want the code owner there because he knows the code best and can answer questions. I don't want the code owner driving the process because the tendency is when I tell you how something works, I say, oh, no, don't worry about that. I already thought of it. It's not a problem. It could be a problem. So the code owner can't be the driver. Tester usually opens the bugs and keeps track of issues that were found, not always. Code review does 2 things. The most obvious one is it drives improvement in the code. The second thing is it educates the test team. And as a consequence of educating the test team, in the next phase of the process, the test team knows more about the components and how to attack them. And they'll use that knowledge. Things we've learned from the code review process, well, the first one's not a surprise. That is, we get better at it over time. The more code reviewing we did, the better we got at it. It is becoming a recognized art in Microsoft. And this should be a recognized art on all of your shops. You should reward the best code reviewers. It's an extremely valuable skill. I argue it's more valuable than writing code is to be able to see problems in existing code. The other one is the first 90 minutes is the most effective. Long code reviews don't work. Don't do it. It just doesn't work. So don't make them too long. Third one is having the code owner talk up front about here's how things work is very helpful. It gives people context. We averaged only about 800 to 1,200 lines of code per team per day. So the process is not incredibly fast. And to my knowledge, I haven't found a way to rush it along. We put up with that speed. Okay, from a test perspective, the testing side is the inverse. All the knowledge that was accumulated during the threat analysis, that allows us to have, here's a set of vulnerabilities this component might be a victim to. The testers were also in the code review, so they understand where the threats are and what's being done about it. The tester's job is to write code targeting those possible vulnerabilities and trying to find something that wasn't found in the code review. And it's amazing. The team's very motivated. If they know where to go and they're well educated, it's amazing what they can do. Another thing that we do at Microsoft, it's in addition to the 3 types of teams I've talked about so far. I've talked about domain specialists in a component. I've talked about test specialists in a component. I've talked about a SWAT team that's responsible for cross-team security. The fourth one is an ethical cracking group. Microsoft has an ethical cracking group. Their sole job is to stay plugged into the black hat community, understand what's being reported out there in the various communications forums used by the black hat community, and target our code with them. When a problem comes in an exchange, the first thing this attack team will do is to go find out if SQL Server is vulnerable to some of the same issues. If a problem is found in Oracle App Server, immediately try it in our software and see if we've got similar issues. Other thing done by the attack team is because these are specialists, these guys know the Black Hat community better than anyone at Microsoft. Another job they do is detailed code reviews. Where we have problem in an area, they target it. The more the problem, the deeper they'll dig down into it. Okay, let's look at things we've learned after the security push. Over 5 million lines of code, what did we actually get out of it? Let me touch on a couple of the important ones. First one is invest in tools early and hard. I'll talk a little bit more about that, but you want to take as much mundane reviewing of code out of the process, and as much as possible use developers for what they're best at, and that's innovation. Code reviews, make the reviews targeted. Give checklists of specific things to look for. Make sure that the code reviews have vulnerability lists and that they have to check off and sign off on each one. If a code review is targeted, it's much, much better than if I say, hey, could you look at this code for me? The more targeted it is, the more effective it is. Clear progress tracking metrics. You need to be able to track the team, and you need to be able to see when sub-teams aren't getting the job done, or they're not making enough progress, or they're just not finding enough in the way of bugs. Let's look a little bit about some of the tools we used. Looking at the bottom of the slide, you'll see some of the tools we used. Some of them have been mentioned already. All of these are in use in SQL Server. /GS, safe exception handling, and no execute. These are wonderful tools that can help prevent. It's backup. And just like Mike said, it's no substitute. There's no substitute for correct code. Another tool that we used, and this is actually still a research tool, but it's been extremely useful to us, is a tool called Prefix and Prefast. Both of these tools, ironically, were originally designed for performance. What they do is they break the software system into basic blocks, and for those basic blocks, a basic block, by the way, is single entry, single exit piece of code. For those basic blocks, they divide the system up and they can track data flow and control flow through the whole system. The reason why they were originally built was to take seldom executed pieces of code and put it somewhere else in the system. You're moving it out of the instruction cache and getting better instruction cache density. What happens is with SQL Server, we get better than 20% performance improvement. But these same tools, the research team said, wow, we can use these same tools to help for the security push. If we know the control flow through the system and we know the data flow through the system, we can find when a buffer hasn't been checked for links somewhere in the system. We use this to great benefit. And this is a beautiful example of one thing you'll find with Microsoft is all the development tools we use internally, we're always looking at how we can make them available to ISVs and to our partners. And the reason for that is that if we can get you better tools, you get better software, and we all get happier customers. So here's an example of industry-leading research that we're getting great value for. And if we can, we'll find a way to productize some of this work. Here's some example defect classes. Now, the reason I put these up is I'd like you to scan through these defect classes, think through some of the tools that I've told you about so far, /GS, no execute, safe exception handling. Then think of managed code. Think how many of these problems could not and do not happen with managed code. There's no substitute for careful code review and careful code writing, but managed code can make a huge difference. And I can tell you back in about 1990, we were writing database management systems in C++, just starting to use C++ at the time. I was very, very careful and resistant to using exception handling in the system. I've got a track record for being slow to adopt new systems. Managed code works. I'm amazed at the productivity increase, but even more important, much more robust code is the results from it. So look hard at where you can use managed code. It makes a huge difference. Okay, continuing down, let's look at what we can do from an application perspective and from an administration perspective on securing database management systems. I'm only going to skim through this because we don't have a lot of time, but I just since a database system is a key part of most applications out there, I wanted to talk about some of the things that you just have to do. The first one is you need to know what software is out there. One thing that Slammer taught me when I'm working closely with a lot of our important customers is their corporate databases are very well managed, they're very well controlled, they're very well patched, and they're not vulnerable. The corporate databases, for the most part, were not damaged. What was damaged is proliferation of other small databases out there that are departmental or personal that people just don't know is there. So the first thing that's important, you've got to know what software is on the network. So inventory the net. Another one is run Microsoft Baseline Security Analyzer frequently. Third one is apply the latest patches. I can't emphasize this one enough. I used to be resistant to apply patches. The thing that cured me, well, partly the security threats that are out there today cured me. Another thing that cured me was and XP has a rollback feature. If you apply a security patch, you can from a device driver or something, you can always go back. And because I know I always can go back, I'm very confident going forward. And so every new patch that comes out, I apply it right away. We've got to get to the point where all of our systems are immediately patched. Use Windows Update or the software update service. Another thing you need to do is audit authentication failures. It's very seldom that a system is cracked through the password entrance without there being evidence of bad passwords coming in. And I like to track both succeeded and failed, and I analyze them for patterns. It's amazing how frequently you will find something. You need to have a corporate policy on security, and this is true whether you're running an enterprise shop, whether you're running a mid-sized shop, or whether you're developing software. You need to say, I'm assuming I'm going to get cracked sometime. Make sure you've got processes in place to deal with it, and make sure that you've got mechanisms for recovering from it. Test those mechanisms. Make sure they work. You've got to go through test emergencies and see if they're there. SQL Server does this. In fact, all of Microsoft does this. We will run simulated drills where we say, we've got a worm that's hit the internet, and we'll scramble. We'll have people called from home. We'll come in. We'll simulate that our network facilities are all down. Our code's unavailable. We'll bring up backup sites. You've got to test in order to make sure it works. Small admin groups, this is no magic. I mean, the more people that are administrators on a system, the more risk there is. Another class of things to work for, because we're seeing the risk go from client systems to server systems, the data is in the back end. Assume the data could be damaged and have great backup strategies in place. Yukon's shipping a wonderful facility that I strongly recommend you all to look at, and that's real-time log backupping. What that we refer to it as data mirroring. Every transaction that gets applied against one system is applied against a mirror system synchronously in real time. There's no single shared point of failure anywhere in the stack. Independent disk drivers, independent systems, independent hardware, independent software. So this is going to help a lot. You need to have a good backup plan in place. You need to have redundancy in the system. And you need to make sure you test it. The first time I tested, I was running a large system at one time some years back, and we'd bought an uninterruptible power supply. The way that worked is if the system crashed, the power supply would keep the CPU running, but we wouldn't have enough strength to keep the disk running. The first time we tested it, the vendor delivered it so that the disk stayed running and the CPU was shut off. So you got to test them. It's just amazing. Okay, things we've covered today. I wanted to show you the demo because I wanted to emphasize that people are starting to build tools that leverage skills, and they're continuing to stand on the shoulders of other crackers. It's getting to be a more dangerous world out there. I'm a server guy, so I wanted to show you that things are changing on the server side and the risk is going up, and I wanted us all to be able to respond to that. I wanted to show you how SQL Server is addressing these issues and what we've done about it, and hopefully you can learn a few things from things we've done. Thank you very much. Thanks, man.
Thank